I want to talk about more around how do we networking in KH clusters, and how do we monitor and observe them, and how do we understand like where our networks is having issues with in our applications specifically. A little about me. Oh, that's a big screen. I'm an engineer at I've been an SRE, I've been an aerospace engineer. I've worked on like rocket science stuff, which is sounds cool, but it's not that cool, I guess. We had an Ansible session before this, so I don't know how many of you were there, but I manage a lot of the open source Ansible tools and also the operator, which is there. And I love football and Formula One. I hope people relate with that. All right. Want to talk about the issues that we face, right? The KH cluster. How many of you work with KH clusters, Kubernetes, stuff like that? Enough of you. Nice. So Kubernetes, like I think you might have faced issues like sometimes the applications are slow, and you might have seen like, all right, there's so many networking layers within the Kubernetes cluster, and you don't really know where the issue happened in the networking layer specifically. The logs obviously would not show anything if you have your application configured around monitoring and like if you have like I made an API request and stuff like that, you'll be able to track that. But all right, where did the API request fail exactly at which networking layer? Because if it's a router issue, if it's a DNS issue, if it's a service layer issue, understanding all of those aspects is very important if you want your application to be 100% up, I guess. Right. So as I said, in a Kubernetes cluster, there are a lot of internal service routing happening, right? From a pod to a service to if you have an LB load or if you have an ingress layer. So there are a lot of networking layers, and we want to track where the latency is happening, where are the drops happening. So yeah. So basically, at the end of the day, we need visibility into the endpoints and how much each layer is contributing to the slowdown in the network, basically, right? This is just an overview of how in a Kubernetes cluster the layers are and how do we already observe them. You might have seen like you monitor your application already, how much is the application using the CPU, the memory, and all that stuff. You might be monitoring your service layer to an extent, the load balancer, how many inputs are there, how many outputs are there, like active peers and stuff like that. You might be monitoring your infrastructure layer, all right, how much CPU is the Linux server using, how much memory the Linux server is using. But what we technically miss around the networking layer is the kernel level, which is at the lowest level. And this is where we can actually track the where the networking drops are happening, right? Cool. The main topic of the discussion was eBPF. I don't know how many of you have heard about it. Has anyone heard about eBPF? Nice. 2, 3, 4, 5. Nice. So eBPF is I don't know how new it is, but it's been relatively like gaining. It's being hyped up a lot in the observability space right now, because for two simple reasons. It's very simple. It hooks into your syscalls. It can track. It started with networking itself, but now it can do a lot more stuff. To be honest, around the application layer itself. It's very easy to use. It's not owned by any specific. Like it's an open source framework, right? And the best part about eBPF for network observability is like it's not a lot of overhead on your application or your infra. If you have a simple enough infra, if you obviously decide to have a very complex infra, it might have some overhead. And yes, the most important would be like it doesn't really require anything in your application to be changed. It's like a zero code thing. You just deploy it, and then it should help you track a lot of stuff. So eBPF is like a like understand it as a framework or a fundamental thing, I would say, right? But to implement eBPF, we need like tools, and this is like one of the tools that I can talk about. But I won't go deep into this because the next tool is what we'll talk about. It's an eBPF observability tool, if you can see. it mainly starts from like monitoring your applications, like how much CPU, how much memory, and stuff like that. But slowly, it was we added like network observability stuff, like how you can track your bytes, how much traffic is happening, and the data can be exported to any hotel endpoint. Have you heard about hotel? One, I guess. Nice. So that tool that you saw, this, we donated this to an open source framework called Hotel, and now it's called as OBI, right? Um, yes, just so that this is like an open source thing. It's not managed by any company or anything like that. So what we're gonna talk about today is how do we do it with OBI? How do you track your networking layers with OBI? Yes. Right. So suppose I have an application, which is obviously a source, one is a destination, and we want to track how much bytes traveled from the source to the destination. If you want to track how much traffic is happening from like zone A to zone B, and then obviously we want the Kubernetes labels around that. Like if I have an AZ in like non in America, and we have an AZ in like say Europe somewhere, right? We want to track how much these two clusters have networking flow over each other. We'll see all of that. All right, how OBI works is like you have a KH cluster, you have a pod, you have an application under the pod. All you need is like to instrument that pod with OBI, basically, right? And then you can send data to any hotel endpoint that you can think of for tracking. Yes. There are two ways that you can do it, like via sidecar or via like a daemon set. Both ways have their own advantages, which I can talk about, to be honest. But preferably like a daemon set, if you have a large KH cluster, it'll be like a daemon set on every node. So it's easier. Sidecar is mainly like if you only want to track like a specific application to an application, which is never really true the case. Like you want to track the whole system, not like a specific application. Right. So once we have like OBI, like we deploy it as a daemon set in the KH cluster, all we have to do in the OBI YAML is like we have to enable like networking because it started with the application. We want to do networking, so we have to enable it by default. You can scan the QR code if you want to see the different configuration options available in OBI. But yeah, that's all you need to do. And since it's zero code, it'll be able to track all of the information around networking. All right. So two metrics that OBI exposes specifically are like around flow, and one is interzone. As I said, flow is mainly the bytes that travel from a source to a destination, and then you can and the interzone is like all right, how much traffic is happening from zone A to zone B. But that's only useful if you have an interzone Kubernetes cluster. If you don't, only the first one is like the most important flow metric that you want to look at, tracker. All right. I want to show a live demo. Hopefully it does work. Live demo never really works. If you want to see the source code, it's a very simple application, and I'll show like how it works online. If it breaks, I have screenshots to save myself. Nice. What all can you see? Oh, cool. I guess. No. Whatever. Cool. If you scan the QR code, good. Because that's what I'm gonna talk about. I'm gonna show. I'll create like a KH cluster live here, and then we'll deploy like an application. Yes. Oh yes. The code is not that important in this, to be honest. The live showcase is a bit more important. The code is like a random application. Imagine any random application deployed in a KH cluster. Cool. Right. What I'll show is like I'll create like a Kubernetes cluster. Is it visible enough? Yeah. Oh, nice. Let's name it test for now. Hopefully it does work. Yes. So we have a Kubernetes cluster and we want to monitor the networking layer. For that, we'll obviously need some application. Otherwise, what are we tracking, right? Yes. Let's up. I have a application which I'll also show how it works. Apply -f. Cool. I'll zoom in a bit more, and we don't need all of this. So we created a cluster. We deployed a sample application. The pods are crash looping, but they should start automatically. They need a database to start running first. While that happens, we also want to deploy like OBI in the cluster as a daemon set, because our essential goal was to monitor the networking layer of these applications, right? kubectl. And if you have anything that you want to ask me, feel free to stop me in between. I'm happy to answer. Apply -f, deploy, OBI. Cool. Cool. We have the OBI as a daemon set. It's a single node cluster, hence you only see one daemon set here. And the rest of the application is also running, right? So we have the application, we have the K8s cluster, we have the networking component deployed in the cluster. And let me also port forward. SVC. Let's go back. Cool. This is the random application that I've deployed. And we'll just trying to make some network requests just so that we have something to see. I can request like a something that I want to eat, a thin slice with spinach, pineapples, stuff like that. Right? I'll make some more requests just so that we have a lot more data to show. And any of you who are judging the choices or the toppings on this, please. Yeah, I don't really control the application. Blame it on the developer who built the application, to be honest. But cool. We made some requests and we deployed OBI. So ideally what should happen is I configured OBI to send data to an OTel endpoint just so that I can track the data somewhere and I can visualize all that how much traffic happened between the applications. My tool of choice was Grafana. Grafana, as you all, I mean, if you know, it supports a lot of data sources, and I have a OTel data source added already, which like OTel compliant data source added in this. Right. So all I want to go is go towards the explore section. I see this metric which is flowing as we saw, like OBM exposed two metrics. Since this was like a single node cluster, we only have one metric right now. And then obviously I can see there's a lot of information within the metric itself. Like I can see the direction, it was a request, not a response. The namespace of the application that made the request, the owner name. I should actually, yeah, this. What type of a pod it was a deployment. And yeah, but what I want to show is we'll go back to the dashboards and we'll see OBI. Right. So this dashboard, as you can see, how much of it is nice. So with this dashboard, I think what we can see, all right, we have an application running, we had the OBI deployed, and now we are able to get, all right, how many active flows, like network flows do we have right now, the throughput, and how many sources and destinations we have, like how many applications are like the source of the networking request, and how many funds are the source of the application networking response, I guess. We can track the total observed traffic. And yeah, I can now imagine like a cluster where, like imagine Netflix, for example, right? We have a lot of users suddenly from somewhere, and we want to track, all right, which region the requests are being made from. And what application is the problematic application here? Like, which is the application that has the highest network bandwidth or like throughput, or which one has the lowest networking throughput? With all of that, I can like if it's a requesting application, I can drop down and change it to a request. And if I also know the namespace of the application, say the application was, let's say Netflix as a single application, right? And a lot of users, like say me, made like I deployed 100 EC2 instances and made like 100 requests to Netflix at the single second, right? And I want to see which part of the networking layer was being problematic, or like which namespace in the Kubernetes cluster was having the highest networking request. I can let me actually zoom out a bit. Oh, cool. Yeah, I can basically see the service to service networking with this, how much inbound traffic each network, each application had. For example, if we take the example of the quick pizza, this app basically, right? How many applications the made to the database, how much was the bytes transfer in each of the requests. We'll be able to track all of that with the distribution as well. Like, all right, the one specific application is hogging the network, right? Here in this case, I know I can see the metrics server is like hogging my network. I'm not even using it. We did not even deploy it. I don't know where the networking bottleneck, like where and why this is using my network. So this gives me a chance to, all right, go to my the KH cluster debug. Why is this even there, and why am I even making request to this, right? If you want to track like the top sources by workloads or destination, you can track that. And all of this graph, this is not working as of now, since I had a single KH cluster, single node KH cluster without any zones and stuff. But suppose if I'm in the US and I'm making a request to Netflix, and there's another one of you, say, who's making a request from, say, Japan, let's say, we'll be able to track all it, which regions have the most amount of request, and which regions are having the slowdown specifically, because our cluster can be, say, in India, for example, right? Japan might be easier to, the networking might be easier from there, but for Americans, the application might be having a slowdown, and then we can essentially track all right, which application was having a slowdown and specifically in which region. Cool. Beyla is also similar to OBI, which I showed, like with the project that we donated to the hotel community. And it's essentially the same metrics, same data, nothing more fancy. But the benefit of Beyla over OBI would be like we have a few, since it's obviously something that we control, we have a few more features around networking. Like you can track the protocol as well, or was it a TCP request, or was it like a UDP request, and you can then filter down, all right, how many TCP requests in this region with this application in this namespace are having issues. So in overall, like what I would like to say, versus that dashboard, like we have the kind of information that me as a networking engineer needs to, all right, go to an application engineer, blame him like, why is this application hogging the database, and why is this application hogging the networking of the database specifically, because we don't want our networks to be blocked at all. If there's no network, there's no application, there's no uptime of our products. Cool. I guess that was the demo, like a small short demo. I can also show Beyla deployment, but it's almost similar. Like it's a Helm chart. You deploy it in a KH cluster. It's similar to OBI. Nothing different. I showed the dashboard. I think it should be fine. And if any of you wants to obviously see what's happening in the the KH cluster, because what I haven't shown you right now is the OBI logs. But the OBI logs would actually reveal to you. The OBI logs would actually reveal to you the sorry. Yes, the OBI logs actually reveal to you all right which network request happened, what was the byte size, and were there any network drop that happened in this request. The dashboard does not show that. I'll have to since I had a time crunch, I wanted to keep it out. But the logs would obviously show all right this packet was dropped, and for this specific reason it was dropped. So you will have the entire information on which layer the packet drop happened. All right. In case the dashboards and the visualization did not work, these were the screenshots I was going to show you. So this is like a backup, I guess. All right. So we have the metrics for the network flow that is happening, right? We have the IPs, the source IP, the destination IP, but all of us know like the IPs can change. IPs are like short-term thing. Like the names might be fixed, but IPs can change very frequently, right? In observability, we want to use labels that are like kind of fixed, not like transient like IPs which can change like say every 1 hour, right? So although IPs might be important to track, but like if you want to make your observability system to be a bit more efficient and not be slowed down, try and not use IPs, like use labels. So we that's like a thing. And if you know like already this CIDR of IPs is like from an internal service load, or this group of IPs is from say a random clades belongs to say a specific application layer. We can group the IPs into a specific thing, at least so that we'll understand which IP group it belongs to, and we'll be able to understand which application at the end was hogging the network. So my advice, if you are starting with networking, is like start with all attributes, to be honest, because you'll have all the information that you need. But obviously, like once you have the information, check out the dashboard, check out the metrics that you have, and filter down like whatever you don't need. Filtering out is the most important part. Like start from everything, to be honest. It's easier. You don't have to think a lot. Let it track everything. But then once you have all right, I just want to know the application names. I don't care about the IPs or the CIDRs at all. Eliminate that from the metric label. Your request would be a lot faster. The database for storing the metrics would not be like slowed down at all. Nice. The cardinality explosion, as I mentioned, like if you cardinality is like having labels which can change. Like IP is something that can change. The label value can change, right? So cardinality we have to control in not just network observability, but like observability in general. So as I said, like start from all, but filter down the labels and the values that you need to be storing. So now I showed you a very simple and a single node Kubernetes cluster, but at a scale of Netflix, which has a lot of Kubernetes cluster, a lot of applications, a lot of infra, the eBPF can still add a bit of a small overhead on your application. It's not much, but that's something that you should account for, because every overhead has a cost. It's not free. Like if eBPF is using to like say some amount of your CPU, that amount of CPU is like co-costing you at the end of the day, because that's not being supplied to or like available to your application at the end of the day, right? And also what eBPF cannot do, or like OBI cannot do, is right, it can track the networking layer or the request, the bytes and everything, but cannot track the HTTP headers that were involved in the networking request. So it's only at the TCP level, to be honest, right? Right. How many of you have seen Cilium? It's a very popular tool for CNI. It's not just for observability of networking, but it's like if you want a proper control of your network in the Kubernetes cluster, that's the tool that you use, and that's also based completely on eBPF, right? Now the issue that would might arise, like if you have Cilium installed, which is using eBPF at the kernel level of the of the Linux node in the Kubernetes cluster, and then you also deploy OBI, which operates at the same level. There's bound to be conflicts, right? Which one is more important? So we obviously have to attach like priorities. Like Cilium can have like a priority of 2, OBI can have a priority of 3, for example, just to make sure that they don't uh, have issues working with each other. And at the end of the day, but my advice, if you want networking for your Kubernetes cluster, deploy both. To be honest, because OBI can give you a higher level information or how much flow happened from an application to an application or between zones. But if you need like the information around packet drops as a metric, I'm talking about. And if you want to control the network itself, the two together work very nicely. You just have to like change a few things here and there, but they do work. I was gonna show a live demo of that working, but I tried to deploy it, but the local Kubernetes cluster doesn't really support that much deployment, and it's a MacBook, so MacBook fails a lot of times. Oh yeah, as I was talking about like the OBI logs, I think here it's very. Oh, nice. Yeah, this is the same information that you might be able to see in the dashboard also. But the logs, although here I don't think we have the bytes drop information. But general, because I think that was not enabled while I was doing this. But yeah, you get all of the information around which where the network drop was happening, basically, and how much the network size was for a specific request. Cool. Some takeaways from the talk. Kubernetes networking is complex, but can be made a bit easier. And it's not cheap to run it. It's a bit expensive. You need a proper understanding of what labels you want to track. Once you have an information on, like, it's not cheap to start with, but it can get cheaper as you understand what labels are important to you, right? eBPF is like a framework that you can use, not on its own. You need like tools like OBI to do the networking tracking with eBPF. And it's generally a very tiny overhead, as I mentioned. But if you have like a very complicated Kubernetes cluster with a lot of applications, it can add like a small overhead, which can amount to a cost. So hence, as I said, like network observability in like complete can be a bit expensive, but depends on how large your Kubernetes cluster is. So yes, I would just start small. Start small, get every data that you can get in, then understand where you can improve, iterate, deploy, and optimize. Yeah, I guess that's all. I guess I ran pretty hard, so I have time for questions if you have any question that you want to ask me. But that was my session. If any questions. Yes. Yes. CNI is supported, but not in OBI itself via Cilium. Cilium is like a CNI tool itself, right? So if you're working with Cilium, you'll be able to manage the CNI network. And Cilium has its own observability also. But the problem with Cilium observability is like you're bound to a specific tool. And if you have like a random like other observability tools and you wanna export data too, that's where like OBI along with Cilium is like a very powerful combination that people generally use. So at the CNI level, like OBI can't do much. It's like just for the network observability, whereas Cilium is like a complete networking tool. Uh, yes, with Cilium, yes. It's most like if you're asking for like the word Kubernetes or like OpenShift, it works in both. To be honest, if you're mentioning about those CNS, um, but yeah, it should work with most of the CNS that are available right now. Anything else? If you don't have questions, or if you wanna rewatch, or like want me to go through because I ran a bit fast through the session, let me know. Otherwise, you can reach out to me on LinkedIn, ask me questions. Happy to answer. Cool. Thank you.